very much for tuning in. Today we are hosting a panel discussion discussing the recently released white paper by Enable Manufacturing with the topic of, is the additive manufacturing bubble about to burst? This white paper was released a couple of months ago and sparked quite a lot of discussions on LinkedIn. People were asking some questions and people raised a few topics that they wanted to know more about. So this really is the purpose of today's panel discussion, to give you guys some answers and to dive a little bit deeper in the topics that were raised. So before we start, first of all, thank you for all our panelists for joining today. And also thanks to everybody who posted questions on LinkedIn and gave us some topics to discuss. We will make sure we address all of your questions in the panel. For those of you who would still like to download the white paper, you can find it on the Enable website at any time. Before we move into our panel discussion, just a few words about ourselves, Enable Manufacturing. So Enable is a UK-based company, and we specialize in additive manufacturing of molds and patterns that are then used to cast metal parts. This process is what we call additive casting, and it combines kind of the best of both worlds between 3D direct metal printing and traditional casting. If you would like to learn more about this, please have a look at our website or contact us, and we'll be happy to speak to you. So, who are your hosts today? So there's me, my name is Anja, I'm the head of marketing at Enable, and I will be moderating the event today and taking all your questions. And with me is my colleague, John Wright. John, if you can give a little wave, thank you. And John is our technical manager, and he will give us a small summary of the topics that were discussed in the white paper, just to set the scene and to start our discussion. But most importantly, who is our panel today? So we have a great panel of experts today who should really help us give some answers and give us more details about certain topics raised. So let's see who's here. So first up, we've got James Reeves. Thank you, James. So James is the Global Director of Polymer Sintering at Voxeljet. And in his position there, James has significant exposure to the global additive manufacturing markets. But James also has many, many years of experience working for manufacturing businesses that are target markets for additive manufacturing. So great to have you here today, James.
Pleasure to be here. Thank you.
Thank you. Then we have Phill Dickens, founder of Additive Scientific. So Phill is a professor at the University of Nottingham and one of the founders of Additive Scientific. Additive Scientific is undertaking research in the manufacture of parts with different materials using additive manufacturing. Phill is also the first recipient of the International Freeform and Additive Manufacturing Excellence Awards in 2009. Welcome, Phill.
Thanks.
Then we have Kieron Stolte, CEO, owner, and founder of KW Group. So Kieron is a mechanical engineer and has spent his entire working career in the motorsports and performance engineering sector, which are, of course, key markets for the additive manufacturing. Kieron brings extensive knowledge about performance engineering, digital manufacturing, and also additive manufacturing to this panel. So great to have you here, Kieron.
Thank you very much. Thank you for having me.
Thanks for joining. And last but certainly not least, our very own Phill Kilburn, who's sales director at Enable Manufacturing. And Phill is higher. And Phill has 27 years of experience in both commercial and the technical field of additive manufacturing. So great to have you here, Phill.
Thank you.
Right. So with this panel in place, I'm going to hand over to John to just give us a short overview of the topics discussed in the white paper, and then we will dive into our panel discussion. Over to you, John.
Thank you, Anja. The additive manufacturing industry has grown by $10.4 billion over the past 40 years, and is projected to triple by 2025. At Enable Manufacturing, we wanted to understand the current state of the additive metals industry to separate the hype from the reality. So in June 2020, we conducted an open survey via LinkedIn, asking engineers and designers how they use additive manufacturing today. The results we collected from the 85 responses have shed new light on this reality. So what is the current state of the additive metals industry today? 82% of respondents indicated that new product development cycles are getting shorter and shorter, placing a growing demand on manufacturing processes that can keep up with this pace. This trend doesn't just affect new products, but existing ones as well. And despite 40% of respondents indicating that they only review manufacturing processes on a yearly basis, there is a growing number who review them on a monthly, weekly, and even a daily basis. So what is the manufacturing reality within these development cycles today? Most respondents said that they consider additive manufacturing during the design process. So why does AM fall short in the manufacture of metal parts? AM still lags behind most common traditional manufacturing processes, such as machining, fabrication, and casting, yet is still heavily considered during the design and prototyping stages. So why is it that the use of AM in the manufacture of metal parts drops off so heavily between prototyping and production? What are the barriers holding us back? The data suggests it boils down to 4 key challenges: cost, quality, scalability, and confidence. Reducing cost is an ever-present goal within manufacturing, and it's no secret that additive metals can be an expensive process. Quality was also a concern for many respondents, relating to the variations in material properties, part porosity, pore finishing, and repeatability. Scalability presents another issue holding additive metals back. To successfully scale production, quantity, quality, and consistency are key. And lastly, confidence. To successfully drive confidence in additive manufacturing, designers and engineers must have confidence in the process, its quality, and capabilities. Driving confidence in additive manufacturing is key to enabling designers and engineers the ability to embrace the technology and overcome these barriers. Thank you. Back to you, Anja.
Thank you, John. Brilliant. So, with no further ado, we have some questions for our panelists, and the questions are have been asked by LinkedIn members and posted to specific people. But please do feel free to weigh in and discuss with the other panelists on some of the topics. So, Kieron, our first question is for yourself. So, are we stuck in a vicious cycle of engineers not designing parts for AM and then finding that manufacturing parts with AM is too expensive? And what do you think needs to be done to give engineers more confidence to design for AM? A loaded question here.
That's a really interesting question, and I've heard it asked a lot as well. But I think the first misconception here is that everybody that designs part for conventional processes also gets it right, and that they come up with the most cost-effective way of designing stuff. I mean, in the good old days when I worked in a drawing office that was near to the manufacturing facility, the way this problem was solved was that if you got the bit wrong, if you used a piece of tooling that didn't exist or cost more money or took longer to make, the guy in the machine shop came up and hit you with the part that he was making, and that's how you learn. You learn quite quickly to design concurrently and design for manufacture. And so you'd go and ask first, what tools have you got? If I want this in pocket radius, what bullnose tip radius is it going to have? And have you got that already in stock? And that's good old-fashioned design for manufacture. And for some reason, it seems to be believed that you don't need to have that same level of due diligence and design for manufacture for AM. You can just produce a part in CAD and send it to a printer and have it made. Those that really know that you need to design for AM in order to get the best out of it. And so the way that we need to solve this is by having capability within our additive manufacturing supply chain that can assist with the clients that are making that move from perhaps traditional manufacturing processes to additive processes. And and we mustn't also forget, additive isn't the solution for everything. It's the conventional machining processes and technologies are still very relevant and still solve lots of problems. And really, AM should only be used to solve a problem that those lower cost, more mature technologies can't. So, how are we going to solve the problem? More design for manufacture, more education, more collaboration within the supply chain, and don't just trying to encourage our potential clients to recognise that before they can make a cost-effective additive manufacturing part, they need to think about how it's going to be made, and that's where they get the best out of it.
Brilliant. So might I just go to Phill Dickens? So Phill, do you believe education will help us overcome some of these challenges?
Well, I think it is starting to do so already in that almost every university with engineering courses and colleges and even schools are giving people experience of additive manufacturing. And so they will be filtering into companies slowly and having an impact. So, you know, that is happening. It's just not happening fast enough. And I think, you know, one of the key opportunities this country has missed is that the government has not put money into giving companies more hands-on experience of additive manufacturing. And it's happening a little bit, you know, and I know Kieron's involved in this in the Silverstone cluster, but you know, that's not enough. You know, we need clusters like that all over the country, and people to be getting involved in this. And the only way that's going to happen is for the government to divert some money into this area. And if you look, you know, I've spent the last 30 odd years researching in this area. There's hundreds of millions of pounds going into research in additive manufacturing. If you look at how much is going into technology transfer for additive manufacturing, it's almost zero. And we've got the balance the wrong way around. You know, what we need to be doing is putting much more money into technology transfer. And you know, that's just something that we've got wrong in this country.
Yeah, I'd agree with that actually. And the other thing I probably should have mentioned is that the bit that's a bit less tangible in the additive manufacturing sort of design for manufacture thing is that it's not as straightforward as speaking to the guy in the machine shop and saying, you know, what tooling have you got? If you're comparing an additive manufactured part with an existing process and you're saying it's too expensive, it's definitely because you've got the wrong bit. You know, you shouldn't be making that part using additive in the first place. So the education piece actually needs to come much further down the supply chain before the design decisions are even made. If you started to design the part with some thoughts in mind, you're already too late. And you know, one of the problems that we're seeing quite a lot is that in the old days you could design something quite easily that couldn't be made. Now we are not able to design the things that exploit the benefits of the way that we can make them. So we're not designing parts that are sophisticated or complicated enough to get benefits out of AM. And when we're looking at the cost comparison, we're looking at part to part rather than life cycle and product development cycle, where you might be actually reducing the cost downstream or upstream by using additive, whether it be through the tooling investment or whether it be through the sort of the maintenance regime or the combination of numbers of parts. So it's actually quite complex to compare the cost of a part when you're looking at additive.
I second that totally. If you're able to compare like for like, say an injection molded piece versus additive manufacturing, it shouldn't be possible to do it, because if it can be injection molded, it probably should be. Yeah. Because it's been designed for it, and if an engineer is good at his job, he will design it for a manufacturing process. So it's got to be designed for AM if it's going to be cost effective. Having said that, Voxeljet runs probably the largest service centre in Europe, and 95% of what we get through is actually designed for conventional methods. We're just supplying it because it's faster and cheaper at low volume. But certainly I think to take it from that level of fast make type work to production, there definitely needs to be more collaboration and design for AM from the beginning. And that collaboration does start with the end users of the parts, the OEMs, the automotive companies and aerospace companies. When they send out to an AM company a single part that's been designed for traditional manufacturing, most likely, and they expect it to be cost effective, and it comes back more expensive, it shouldn't really be a surprise. But what they should do is they should send the assembly and say, right, we've got all these different parts. What could you do to reduce the number of parts? Or we've got a structural load to put between A and B. Can you help us design a part to be made, rather than sending the finished item out there and expecting AM to be cheaper?
But do you think it's still a brave engineer that's going to make a commitment on day one that parts can be manufactured using additive manufacturing?
Yeah, absolutely. and it needs to be, as I say, a collaborative effort between the company designing the part, the end users, and the supply chain of AM to get that confidence.
Well, there's certainly a lot of challenges ahead still for this industry to grow, but with people like yourselves, there's certainly a lot of scope to drive things forward as well. Okay, so let's have a look at our next question. So our next question has been asked to Phill Dickens. So Phill, in your view, do you believe that AM for plastic parts has developed faster than AM for metal parts? And why do you think this is happening? And are certain market applications driving this trend?
Well, I think additive manufacturing has taken off more for plastic parts than metal so far. But that's probably, I think, due to the machines that have been available over the last 10, 15 years or so on. I mean, it's only fairly recently that we're able to get pretty good quality metal parts directly from an additive manufacturing machine, whereas we've been able to do that with, say, selective laser sintering for quite a long time. So I think there's more experience of getting good quality parts from plastic machines than there is metal, but that is changing now. So it's now possible to get really good metal parts from a laser fusion machine, for example, or an electron beam machine. So I think it will balance out over the next few years, and I think you'll probably see rising numbers of metal parts coming from machines. The issue you've got, I think, is that metal processes tend to be a bit slower than the plastic processes. So there's a cost issue there still.
Yeah, I would add that one of the reasons why polymers has perhaps been adopted so much more quickly, or apparently more quickly, is because of the cost of entry for doing that as well. It's relatively low cost. They're normally for relatively low risk parts, not safety critical parts. The market for those type of parts is broader, but certainly from my own experience, I can say that the investment in equipment to manufacture and process polymer parts is certainly a lot less than the infrastructure you need for metals. I think the downside of that, though, is that because of the relatively low cost of entry, just about anybody who's got a bit of cash in their pocket can go and buy a 3D printer of some sort, and that has really hurt the credibility of the process, and very much been seen as a prototyping or a sort of a maker type process. And actually, the really sort of high-end engineering plastics that can be manufactured in some of these parts are very good and have very good applications. So it hasn't had quite the same hero status that sort of utopia of printing metals has been. But certainly its own sort of Achilles heel is the fact that it's relatively low cost to entry.
Yeah, I totally agree with you, Kieron. It's the low cost of entry. It fires up some application areas because people can try it really, really cost effectively. But the number of potential customers that I talk to about sort of supplying them with parts from our powder bed process say, oh, we've got a 3D printer, we prototype on that. Yeah. I generally say to them, I'm not looking to replace your in-house prototyping machine, because that's fast turnaround stuff. I'm talking about higher volume and higher quality. But they still struggle to understand that there's a difference between a £1,000 FDM machine and a £200,000 laser bed machine.
Mm-hmm.
Great. So we actually do have a question also later for Phill Kilburn that kind of addresses this. So before we go to James, I think we'll go there first. So somebody actually did ask the question. So we all accept that a 2D printer at work is not suitable for printing professional marketing material, for example, and we will outsource this to a professional printing company. But why do you think is there such a difference in attitude for 3D printing?
Yeah, I think this fits in quite nicely, actually, because one of the points I wanted to make was the fact that you can buy a 3D printer now for less than £300 off the internet. I was quite surprised. I didn't even think they were that low. But if you think back to when me and you, Phill, started Phill, it were people with PhDs. It normally took a day to start off one of these machines. I had 3 computers to get them going, and it was very rare you got a part coming off first time, and so quite difficult. Whereas now you've got a plug and play model coming off straight away. So I think it's kind of opened the market up, but it's made it more difficult by the fact that you've got an engineer who's found this on the internet. He's making the parts in house, and suddenly he's becoming that in-house expert for producing these components. And people are asking him then, what can we do? What can we do? And he's limited to what he's got there in front of him. So when they go to upgrade or expand the capacity, they go to what they already know. They don't look at what else is out there. And so if they're looking at an FDM machine, for example, people are going to sell them another FDM machine because they don't want to send them somewhere else. Right? It's not going to be viable for them. And I think that we assume that people who are involved in the market are using 3D printers are actually going to places like Formnext and TCT and looking at what's out there on market. And they're not. They're too busy making money on a day-to-day basis and making models for what they've got. And an example of that, my next door neighbour's involved in automotive, and they bought a machine off the internet. They thought it was great. They were making fixtures. And over a beer one night, we were sat talking about this. The parts that he was making and using weren't right for what what his application was. So I went in and we looked at it. He went out then, he used a service bureau, built SLS parts in a glass-filled nylon, heat resistant, which is what his application was, and his productivity went up because of it. So I think people have got a very blinkered view of what's going on out there. And the desktop printers have opened it up to more people, but actually it's restricted the applications as well.
Yeah, I think there's also a perception that one technology will suit every need. I said to many people before, buying a lathe doesn't make you a machine shop, and it's the same with AM. You can't just go and buy one technology and think you're going to manufacture every single part you need. So there seem to be some very strange misconceptions that I think are just a legacy of additive manufacturing being from relatively low-tech materials and relatively low-tech technologies and producing what we would call prototypes and model parts.
Yeah.
But yeah, it's funny how many people think they can just go and buy a machine and they can make everything on it.
Yeah, but I think it comes back to education again.
It's interesting how it's like that in this sector, because if you look at other sectors, obviously with Voxeljet we supply the foundry sector, and in the UK there's 450 different foundries, and there's that many because they specialise in one metal or one casting process or one quality standard, military, nuclear, whatever it may be. So that you go to the foundry that gives the best solution for the particular part that you want. But with AM, it's like if you're an AM provider, you provide AM parts. People don't understand that there's a difference in processes and quality and all that sort of stuff.
You don't get casting service bureaus, do you?
No.
Well, that's certainly interesting, and will be also interesting to see what people say on LinkedIn when we release this video.
I'm sure.
So going back a couple of questions then, because we skipped a question for James, so just give me 1 minute. So we do have a question for James. So James, do you think if more people start to adopt AM for the manufacture of production parts, we will have to consider printing material and recycling marks on the parts?
I think the short answer to that is yes. We need to, if we're a future manufacturing technology, we obviously need to consider the circular economy and recycling. It's critical that we do. It's not just the recycling, but it's the energy and consumable consumption within the processes as well. At the moment, recycling within the AM sector is mainly focused on recycling unprinted powder and making sure you can reuse that. But it needs to move a step on. It needs to go beyond that and looking at using recycled materials and the recycling of parts printed. But I think the long answer is that it opens up a huge debate around the materials, which is true in both metals and polymers. On the polymer side, there's about 85,000 different injection molded polymers that you can choose from. So pretty much any sort of thing that you need is available. And in AM, there's maybe 100 or something. And it's really hard in those service centres that we just talked about to find ones that have the exact material that you want. So at the moment, everybody is compromising on the material choices, and it's exactly the same in metals as well. There's still not that many metals out there, and they are different. And that's something we have to accept, is that any manufacturing process forms a material in a different way, and it will have different material properties. So the end user has to be educated that you will get a different material property. You should never expect it to be the same. A forging material is different from a cast material, is different from a machine material, and different from an AM material. But there's a massive amount of work in the AM sector to qualify more materials. And then if you add the recycling of those in, there's even more work to do. It's probably a barrier, going back to the survey results, it's probably one of the barriers that exist. You know, you can prototype in a similar material, but when you go into manufacturing, you want the material, and that's probably not available at the moment in AM. But from Voxeljet's perspective, on our powder sintering processes, we've got a backlog of something like 25 or 27 different materials to qualify that people have asked us to qualify. And each material takes a minimum of 6 months to go through the whole process, to understand it, to get the process settings right, and look at consistency and conformity across builds. We then add in recycling to that, and it takes even longer. So we've got decades just at Voxeljet, decades of work just to qualify the materials that people have asked us for today. If we're trying to get to 85,000, there's a long way to go. And to add in the recycling just adds another dimension. But it needs to happen. It does need to happen. And in fact, I recently contacted a polypropylene project, a recycling project for polypropylene, which is an EU-funded project. And I contacted them in a hope we could do some sort of work together, appreciating that AM sector is very small compared to other polymers. Polypropylene gets used in carpets, for example, so there's loads of it floating around, but they simply were not interested to talk to me at all. They said, we're not interested in 3D printing, it's just too small for us to get involved. So it's a real struggle, actually, as an OEM to manage this workload, and we definitely need, like we said before, we definitely need more collaboration from the materials providers, from recycling projects, from end users, about which materials to qualify first, and how much recycling needs to be considered within that. I think, a bit like we've mentioned before, there needs to be a bit more intervention from government to help both on the materials qualification, but then you can add in the recycling to that. You need funding, you need projects, you need cross-sector coordination. It probably comes down to a trade association. We don't really have a trade association that is focused on AM. It gets bolted on to other trade associations, and they all do a little bit because they see the market growing and they want to get some more members. But there's nobody focusing on AM solely across the sector, and maybe that's something that would help, certainly in the UK and maybe more widely across Europe, in terms of bringing all these needs together, because a lot of people dump it on the machine manufacturers, but to be fair, the machine manufacturers are focused on their machines and they can't do everything. So there definitely needs to be some cross-sector support in all these areas.
Brilliant, thank you, James. So if nobody has any more comments about this question, we will move on to the next one. So our next question is again for Phill Dickens. So Phill, what do you think will be the next really commercially successful AM application? And do you think it will be an AM product or just a hidden component?
Well, I think in general, I think probably the biggest area for additive manufacturing in the future is probably going to be anything to do with medical, whether that's plastics or metals, because you tend to have the complexity there, and also cost can sometimes be less of an issue. I mean, certainly, if I think of the work that we've done at Additive Scientific, probably the biggest potential area was a medical application, and that was partly down to complexity, geometric complexity, just the capability of the process. But I think we're going to see additive manufacturing in pretty much every sector. There's the only sector I don't really see it taking much active part is actually in farming. Every other sector it will be there, even farm machinery or whatever. So it's just down to a timing issue and cost, really. So it's certain companies come to us and they've identified that they want to make something by additive manufacturing, usually because they can't do it by the existing processes. And that will just grow. And so it will become a more mainstream manufacturing process. Just like, if we think back 30, 40 years ago with electrical discharge machining, when I did my degree, electrical discharge machining was called a non-conventional manufacturing process. Whereas, now you just think, well, it's just a normal manufacturing process. And additive manufacturing will become the same.
In my world of digital manufacturing, as we're now calling it, because it's broader than just additive, we've been involved in everything from inkjet technology to binder jet and laser systems. The whole concept of additive is it doesn't have to be a truly large-scale three-dimensional shape. And to give you an example, one of the projects we've been working on with some funding from the Faraday Challenge was using digital deposition techniques, which essentially are additive manufacturing processes, to make electrodes for batteries. And the reason we're doing that is because it gives us accurate control. So rather than an analog sort of broad brush process of applying coatings, we're able to control that coating, and essentially we're building up 3D layers, but they're very thin. So when you look at it, you think it's a 2D object, but they're not. It's a complex 3D object. And I think that's where some of the future of additive is how you hybridize some of the technologies and manufacturing processes that give you multi-material, multifunctional components. And the real benefit perhaps of additive, two benefits I think of additive generally are being able to make things that you couldn't make before, but also being able to make them at minimum order levels of one. That's the real advantage in the future. There's the mass customization thing, which from a medical point of view is really important, but that applies to many other sectors also. And going back to the environmental bit and the recycling point, it has a part to play in that also, because we can reduce the amount of stock that's held. We can reduce the amount of material that gets unnecessarily converted into end-use parts using energy that we didn't need to use. And we're only using the materials that we need to use and storing them in a generic form that allows us to make any part that we need out of them. So I think we've really got to understand why additive or why digital, more importantly, and exploit that to its real benefits, rather than trying to just make another process that makes parts, as James said earlier, in a way that already works really well.
If I was going to answer the original question about whether it's a component or a 3D printed product, I'd go component. I don't really understand this drive to 3D print a whole thing. Like, there's so many 3D printed cars out there. If you 3D print a whole product like that, then it's just going to be ridiculously expensive. There is always a place for traditional manufacturing. So if you engineer a solution, it may well have components in it that are 3D printed, but it's not a 3D printed product.
So your 3D printed product could be a sensor, which is a multi-material, level component that is not assembled but actually made in one go, using different materials and different processes. It doesn't have to be a car.
True. I just like to see. I see these some of these marketing stunts, and I find them quite funny.
Yeah, I think the other issue to bear in mind as well is that, you know, one of the reasons that we certainly got interested in this as a manufacturing process in the mid-90s was because of tooling. And tooling is still an issue. And so, there's I know companies that go down the additive manufacturing route simply because they don't want to invest in tooling, either because of the cost or the time, or it locks the design, or there's lots of different reasons why people will avoid tooling if they can.
Yeah, agreed.
And I suppose with the savings in inventory holdings, that is another big incentive for companies to eventually go that way and then save that money on tooling and on inventory, have more cash available. Brilliant.
Yeah, I think there's lots of opportunities there in the spares area. We're actually doing a project with MOD at the moment to look at using additive manufacturing to supply spares for the military, and in certain applications I can see a real benefit there, and that will be the same in lots of other companies.
Yeah, excellent. Okay, let's move on to the next question. So the next question is kind of an open question for the entire panel of experts, so just feel free to weigh in at any time. So on the graphic here, we're displaying kind of the hype curve of technology, where we have an innovation trigger, and then there's huge expectations about what technology will deliver, and then a huge disappointment of what it's actually delivering. And we feel that AM has gone through a few of these hype curves before. So the question for the panel is that, do you believe that AM is now an established manufacturing method, or do you think AM will still go through more hype cycles? And do you think this might be different for metal or plastic parts?
Absolutely, it'd be different for different materials. I think perhaps from my view that generally additive manufacturing is on the slope of enlightenment. I think people are we've been through the disappointments, and people are seeing that there are real opportunities in additive manufacturing as a technology. However, every technology and every material, I think, is in a different stage, and sort of polymers, as we said earlier, pretty advanced. Metal's still quite immature, and many other technologies and stuff coming out all the time. So there's going to be a hype curve almost for every single one of those. And I think a bit like the consumer electronics market, I kind of expect that additive will continue to evolve very, very quickly, with lots of new technologies and lots of new things coming out regularly, rather than sort of the previous traditional methods of manufacturing, which have been well established and unchanged for many years, except for perhaps the advent of CNC machining over traditional machining. So I expect to see it changing a lot, but I think generally additive is accepted.
I generally agree with you. I think, Kieron, as you said, I think every application is at a different stage on that, and on the slope of enlightenment. I think things are looking up, and I think people are, certainly in the higher tech sectors, they're expecting additive manufacturing to be a manufacturing method rather than just a prototyping method. So they're looking for opportunities to get it there.
Yeah, they believe in it.
Yeah, they believe it will happen. There's obviously we've
identified who can do it yet.
Quite a lot of barriers today. So there's a lot of stuff that needs to be overcome, but I think it's on the way up.
I think we're still pretty much in early days, really. Even though a lot of us have been in this for nearly 30 years now, it takes a long time for a manufacturing process to become really well established. And if you think of CNC machining, invented in, I think it was 1951, and it wasn't really until the early 90s, mid 90s, that it became a really good manufacturing process. So 40 years. So and then you look at electrical discharge machining. Again, it took a long time for it to become a really well established manufacturing process from when it was invented. So I'm sure we're going to get there, and it will become much more widely used than it is now. I have no doubt about that at all. But we've still got quite a bit of work to do. And I think, going back to my earlier point, getting people like Phill did with his next door neighbour, you need people to do a lot of hand holding to get them through this. And that's what we really need at the moment. All the additive manufacturing processes, I would say, are useful at the moment to someone. And so what it really needs is someone to go around doing lots of hand-holding, saying, this is the one you want to use, and this is how you should be using it. Yeah. And if we could do that, we'd be in a fantastic place.
Yeah, I think we've had a lot of false starts, but I also think we're now sort of patting each other on the back, saying we've done a great job here, and we haven't even started it yet. I think a lot of education still needs to happen, and I think there's still thousands of applications out there that people that still don't even know what additive manufacturing is, to be quite honest.
Yeah.
People, we're a small industry, but we're thinking we've done a lot more than what we actually have.
So can I ask the panel, just your educated guess, how long do you think it will take until additive manufacturing is really comfortably established within companies in one way or another, for plastic or metal, but that people really use it in production and mass production parts?
I guess it depends on what you mean by established, really. So Voxeljet is installing a production line on the print and cast type, the sand printing and casting metals, to manufacture 200,000 engine components per year, critical engine components for the automotive sector. That's being installed as we speak. So for that end OEM, who I can't mention, it is there. But for many people, they don't even know what sand printing is and metal casting. Yeah. So there's a lot of work to get it adopted broadly across the sector. And on our polymer side, we're a little bit earlier with our technology there, but we are talking to customers about 20 to 100,000 units for serial production. So it is coming, but these are application areas where people have understood from design, initial concept design, about the manufacturing process and designed for it. So there's a lot of education, as we've already discussed, through the whole supply chain to make these applications work. So it's nearly there in some companies, but it's probably another decade before it's well established.
Again, it's application and technology specific, isn't it? The answer to that, because as I understand it, in the dental industry, additives being accepted and almost exclusively used for various things for a number of years now. It's just finding the right application and the right technology match. So I think in some cases it's already there and it's been happening for a long time. In many cases we're still a long way away.
Yeah.
Okay. That was our last question for our panel. So would anybody like to make any closing comments or statements about how you feel about the industry, or where you see great opportunities, for example?
Well, let me start then, because I've just been up to see my new facility that's being built up at Silverstone, and I'm very excited about that. So, 20,000 square foot of dedicated digital manufacturing space. I think that hopefully underlines a confidence in the sector, a confidence in UK manufacturing. We want to be part of the UK supply chain. I think this kind of technology might well be part of the recovery of our economy and technology post-COVID.
Yeah, I agree with that. I think, if there's one good thing to come out of all this palaver with COVID-19 at the moment, I think it's people reassessing supply chains.
Yeah.
And I think additive manufacturing has got a massive role to play in looking at how those new supply chains should be working. And And if we are going to start making things more locally in the UK, I think additive manufacturing has got a big role in that.
Totally agree. We have seen it actually already happening. Certainly, even before COVID sort of landed in the UK with the supply chain disruption from China, because obviously Voxeljet's mainly in the print and cast sector. So a lot of castings coming from India and China, and that supply chain got disrupted very early on. Yeah. And the foundries in the UK were asked to meet the demand, but companies didn't want to invest in more tooling, so it was print and cast. Pretty quickly sort of became used quite a lot. So I think you're right with that opportunity.
A lot of companies looking to reshore, without a doubt. But I still think there's a lot of education, a lot of missionary work still to be done.
Yeah,
I've been saying that for 20 odd years.
Well, it's certainly good to know that it's not all doom and gloom, and there's lots of opportunity to move forward. That's for sure. All right. Well, I don't want to keep you for too long because I'm sure you are all busy. So that is the end of our panel discussion, unless anybody would like to share anything else. But if we are at the end, then I would very much like to thank our panelists for taking part in this discussion today and for giving us these really interesting and useful insights into some of these topics. Thank you for that. And should anybody have any questions after watching this recording, they can pass them on to me and I can pass them on to the panelists and get them answered. So thank you, panelists, and thank you to everybody who posted questions on LinkedIn. And we'll hope to see you soon for another version of a panel discussion.